Hello again, I'm Dr. Jordan Taylor, Undergraduate Exercise Science Program Director and Associate Teaching Professor at the University of Kansas. On today's episode of Fitness Facts, we have a special guest appearance by Dr. Andy Fry. Dr. Fry is a professor in the Department of Health, Sport, and Exercise Sciences at the University of Kansas. After obtaining his bachelor's degree in physical education at Nebraska Wesleyan University, he earned his master's degree in exercise science from the University of Nebraska and his doctorate in exercise physiology from Penn State University. During his 2-year post-doctoral training, Dr. Fry studied cellular and molecular muscle physiology at Ohio University. This was followed by 13 years at the University of Memphis, where he was the director of the Exercise Biochemistry Laboratory. Since arriving at the University of Kansas, Dr. Fry has spent considerable time developing the Jayhawk Athletic Performance Laboratory. His research interests over the years have consistently focused on physiological and performance responses and adaptations to resistance exercise, as well as overtraining. He has also been very involved professionally in the field, serving on the National Strength and Conditioning Association's Board of Directors, including one term as vice president. He was recently honored by the National Strength and Conditioning Association with the Boyd Epley Lifetime Achievement Award for his contributions to the profession. Dr. Fry specializes in resistance exercise, skeletal muscle physiology, endocrine responses, and adaptations to exercise, and overtraining. Welcome to the show, Dr. Fry. All right, so you've been working really hard putting together the Jayhawk Athletic Performance Laboratory that we're sitting in right now. Can you talk about kind of the toys that are in here and what you can measure and study in the lab?
Yeah, well, welcome to the lab, and it is neat, like you say, that we're sitting right here in the middle of it. We're actually sitting on our sprint runways. We have a regular track, a Mondo track here, that you might have at any track and field facility. You're sitting on the turf side, so we can assess the agility and sprint performances right here in the lab. And of course, if we need longer distances, we can go to the sites.
Assess it with radar.
Here we have a radar system that we'll set up, and it's actually, I think, across the street at the athletic department right now, but we track sprinting by radar. We also have a camera system that's being developed that can track you however far you go. And so we not only get times, but we also get how you get there. What is your, coaches talk about first step speed all the time, but we can actually measure it, and we can see why is that running back so good at hitting the hole quickly. Well, in the first 2 steps, they're this far, their acceleration is whatever. I mean, we have the ability to tease that kind of stuff out. So that's just one piece. This side of the lab that I'm facing, we keep it open because we have a batting cage, pitching machine, we have a TrackMan ball tracking system. At times we've had our basket set up there depending on what we're doing, but we keep it open for a variety of activities. We can throw medicine balls, we've had footballs thrown, and so it's a multi-purpose open area on that side.
And I remember, and you talking about that, I remember a few weeks ago we were talking, I think you looked at something with hitting mechanics, and you looked at exit velocity, and was it torque on the front leg?
Yeah,
if I remember right.
People that are in the world of baseball or softball are very familiar with something they call exit velocity, which is also called batted ball velocity. What is the speed of the ball coming off the bat? And if you go to, anyone who is scouting an athlete, or you go to a baseball showcase or combine, that's a very standard measure. And you hit the ball off a tee, and there's a radar that sets up and measures, okay, what is the velocity coming off the bat? What we were interested in is not just what is that speed, but how did that baseball player actually generate that force? Because the force gets generated, they stand on the ground, and that force gets transmitted up through the body and out through the end of the bat. And obviously you have
kinetic
to
chain.
Yeah, exactly. And so what are those forces? And a lot of people think, well, those are vertical forces. What does that have to do with rotational forces? Well, that's where the baseball coach steps in, because they teach proper mechanics, technique to convert that vertical force into rotational force. And obviously you have to have the eye-hand coordination, and you have to know the skill. But we had our players hitting on force plates, so we could see the rear foot force, the front foot force, and how that related. And we actually saw that the front plant force is pretty strongly related to the batted ball velocity. And some of the take-homes were, well, you need to, a large player has more force. That's why quite often your power hitters are larger athletes. But also, you can make anyone stronger too.
Right.
And that translates. So the strength coach can make a person stronger, and they can help them get a little bit bigger. They can't make you taller, but gives us some insight on, okay, so what are the contributing factors to successful batting performance, and which ones are trainable besides the skill piece. You still have to have the skill. But so that was a real fun study, and we did that right in here.
And you know, it's interesting when you talk about putting force into the ground, and I've had strength coaches ask me about this. A lot of times athletes, you know, they're scared of, you know, lifting too much and becoming muscle bound, and they think it's going to slow them down, say in track or on the football field or whatever sport. And it's like, well, that's not necessarily true, because, you know, if you gain some muscle mass, you're probably stronger, you can produce more force. If you put more force into the ground, down and back, the ground reacts with an equal and opposite force up and forward. And one of the main things you get with improving speed, if you're stronger, is an increased stride length. So, I mean, stuff like that you can look at in the lab, I think, is just really cool. And like you said, you mentioned, we've got the force plates over here. Also, I guess the Dari motion capture system, that markerless motion capture system, that's really cool. Maybe you could talk a little bit about that Dari system.
Yeah. Well, you know, I mentioned we're sitting on the track here, surrounded by cameras. They're plugged into this Dari system, and Dari stands for Dynamic Athlete Research Institute, and they're based in the Kansas City area. And we have a long history of working with them since they were just an initial startup company. And in fact, some of their initial work on their beta versions were done right in this room before we were up here. But over in another corner of our lab, we have kind of a permanent setup of cameras that can evaluate your motion. So there's a lot of systems that can do that. A lot of them require me to come and put a marker on various joints, your shoulder, your everything. And
it's like how they used to do motion capture for video games. Yeah.
And so, and they're very good if you have that much time, because it takes to do a full body setup 20 minutes plus just to put the markers on. Hopefully they don't fall off. Since we're talking about baseball, good luck keeping those markers on a pitcher throwing 80, 90 miles an hour. The nice thing about this system is called a markerless motion capture system. So it's specialized cameras that capture the motion, and I don't need those markers. It can see you, and the algorithm says, this is your body, here's your knee, your hip. And so it's way quicker, and much of their software turns the information around very quickly. Otherwise, it's a slow turnaround. And the nice thing is we're working with them, whether it's the sprint lanes, whether it's looking at other measures, evaluating your ability to move, balance, coordination, strength, ranges of motion.
Looking for asymmetries, I know, on either side of the body.
And so that is a nice tool. And so we work with them here in the lab, and we can take the system out on the road at times. We took it to a professional basketball mini camp here a few months ago, and we're assessing their athletes. And so it opens up a huge door of opportunities.
Right, I mean, it can be used for looking, like I said, asymmetries. Then you could tailor a strength program around that asymmetry to, help prevent injuries. I mean, it just has so many ways that it can be used. It's really, really cool. All right, so on to the next question here. So can you talk about, and we kind of got into it a little bit, but maybe just highlight a few studies that have been published and that have come out of the lab.
Yeah, well, some of the recent work, we have a real strong focus on basketball. And because of that, and I'm not a basketball expert. I love watching it on TV. I'm a huge Jayhawk basketball fan, both the men and the women, and they both had good years last year, to say the least. But that's not my area of expertise. So we hired a full-time director of basketball research, and he's actually will be returning from Europe on some lab-related work. He'll be back soon, but he has really spearheaded a number of projects. In a very general sense, some of the things we're looking at is what are proper shooting motions. So in doing that, we talk to a lot of coaches, and we have an advisory board for our lab. The advisory board is entirely coaches or retired coaches, because we want people who not just are fans, we want people that this has been their career, and their career has depended on being successful. And that's invaluable. And so when we look at things like what's proper free throw shooting motion, what's proper 2-point and 3-point shooting motions. In the coaching literature, there are many coaching cues that have been used, and many have been successful. And we said we want to look and see which ones seem to tell us the most.
Right.
And so we have done a number of studies.
Should you prioritize certain cues over other ones?
Yeah.
Right.
And we understand every player is a little different, but there are some distinct patterns that differentiate the successful basketball shooter from the less successful. And so we find that it agrees with a lot of the coaching literature, but there's some that it's like, okay, this appears to be way more important than some of these other cues. And that's stuff that any coach can take and put to use. And that's been really fun. So we're either doing that work right here in this room, or across the hall we have a full basketball court that we often use for this kind of stuff as well.
Yeah, and I want to bring Dimitri in for one of these interviews to have him talk about Dimitri Shabarkaba. He's from Serbia. I want to have him come in and talk about some of that research that he's done, looking at the biomechanics of shooting. It's really interesting. All right, so we'll move on. Let's talk about this lab is part of the Tsai Human Performance Alliance. Can you kind of talk about how this alliance was formed, the members that are in this alliance, and what its purpose is?
Yeah. So several years ago, I got a cold call. It was just about the time COVID was hitting, and so I was working at home, and it was from an individual I didn't know. His name's Tom Skalick, and he is in charge of a huge foundation that it's called the Tsai Foundation, and they fund the arts, and they fund social justice issues. And for years they had been interested in getting into the medical research area. And after a while they said, instead of looking at illness, disease, injury, let's go to the other end of the spectrum and look at what happens when the human body is functioning on all cylinders. Well, what's a good population for that? How about elite athletes? Why does Usain Bolt set world records? Why does LeBron James perform at the level that he does? What's the difference between that first place gold medal winner at the World Championships and the 8th place guy who is really, really good? He's the 8th best in the world, but there's still a difference.
Or the other end of the spectrum, like you said, the person that has COPD and they can't walk up a flight of steps. That's high intensity exercise to them, right? It's really interesting how, and I think this is a huge issue in the United States. It's like we tend to be reactive with our health instead of proactive, and athletes are obviously, because of their job description, they have to be proactive. They have to be in top physical condition. So, if going on my tangent here, my rant, but if more of us were proactive about our health instead of reactive, you know, we wouldn't see so many of these lifestyle diseases, the type 2 diabetes, the cardiovascular disease, the cancer. But I'm sorry to cut you off. I'll go on my tangent here. But that ties into the research that's going on and the purpose of the WUSI Alliance.
So what ended up was a group of 6 universities were selected to become part of this WUSI Human Performance Alliance. And the premise is, if we can understand what happens when humans reach their potential, then that information can trickle down to the average person or to the person that is dealing with illness or disease or some disability. And the analogy we like to use in this lab is the auto industry. And NASCAR, Formula One, Indy cars, the technology in those vehicles is off the chart. It's phenomenal if you ever get a chance to hear about what they're doing. I don't have that in my pickup truck. You probably don't have it in your family car or whatever you drive. But in 10 years, we probably will.
Right.
And so that information, even though that's on one hand, it's a small segment of the total auto industry, it's so critical to understand for the broader use. And so the same approach is being used here. We're studying athletic performance and the journey to reaching your potential, and that information will eventually feed down to more everyday uses or for fighting illness. So we don't study illness, we don't study disease. I'm not a clinician, I'm not a medical doctor. I don't directly study injuries, but we study things that can influence that.
Right, right, which obviously is important. I mean, this can improve human health. I mean, if people apply the findings, right? That's key. All right, so kind of changing course here in our discussion. Let's talk about some of the factors involved in muscle growth. And, you know, I think back to kind of how research has developed in this field. You know, you go back to like the 70s and 80s, a lot of research in exercise science was based on cardiovascular function, aerobic exercise, the cardiorespiratory system. Now you're seeing in more recent years a lot more research coming out on muscle hypertrophy, growth, things like that. Now I know you've been doing, you know, in the past and with Bill Kramer, research on hormones, acute hormonal responses to resistance training, things like that. So we know, you know, genetics play a role in muscle growth. Obviously muscle tension, applying a load to the muscle, that's going to play a factor, that mechanical tension, stimulating those anabolic intracellular pathways that promote growth. Nutrition, obviously things like adequate protein intake, adequate calories. The design of the resistance training program, which we could do a whole talk on that, you know, all these variables, frequency and exercise selection and velocity and sets and rest period lengths. I mean, there's so many variables. We could do a whole talk on that. Then there's also biochemical, metabolic factors. And then, like I said, the hormones, which is kind of what I want to get into and kind of focus in on out of all those variables that are related to muscle growth. You know, there's been some research kind of published recently in certain labs that say, you know, acute increases in anabolic hormones like testosterone and IGF-1 and growth hormone during and after a resistance training workout don't really matter as far as stimulating muscle protein synthesis and muscle growth. Now this is kind of getting into your area. What do you have to say about that?
Well, I'm glad you asked because you're right, this is my area. And one thing, and I tell my students this, when you read what is being published, look and see where that information is coming from. Who's writing it? Are they people that actually work in that area? Do they have an expertise in that area? And just because they may be popular on social media does not mean that they have an expertise in that area. That's been their focus. So look and see what's the source of the information. And then also, I would say that the individuals and the labs that are saying the hormonal response to exercise has nothing to do with muscle growth, I couldn't disagree more. And I'll tell you why. There's a couple things. One is this has been an area we've studied for a long time. We also know that it's easy to oversimplify things. Right. Now, I understand that there's approaches saying, you know, usually the simplest answer is the best answer, but your body is a very complex system. And if we come in, we say, tease out one variable and say, that has nothing to do with how your body functions, how it responds, that's a pretty broad stroke statement.
Right.
And I would say, well, it depends, because your body is built so amazingly. You have so many systems that overlap that it kind of as a safety net.
Right.
And so, so that's where I think it's easy to just look at one variable and they say, I did a study and we didn't see a relationship, so it doesn't exist. Right. If you read those studies, and when I say read them, you got to read them carefully. Don't just read the social media post. Don't just read the title. Don't just read the abstract, which is the little paragraph at the beginning. Read through, and if it's outside of your area of expertise, you have to have enough knowledge to know, does this make sense? And many of those studies, and we talk about this in our classes, and many of those studies, you have to look to how well designed are they?
Right.
And one of the criticisms is they'll say, well, we did a project, we had people do resistance exercise, and we didn't see any hormonal response. And so it must not have anything to do with muscle growth. Mm-hmm. It's like, well, there's a lot of exercise sessions that may not stimulate a particular hormone. That doesn't mean that it's still not serving a function. You have to look at what was the workout that you had the individuals do. Right. Was it even a good training session?
And then when you're talking about design, and there's limitations in every study, people got to understand that. There is no perfectly designed study. That's impossible to correct for every little variable. But we talk about time points. It's like, did they miss the time point? When were time points measured, especially with hormones? I mean, the various hormones we release, they have diurnal patterns. I mean, like cortisol is high in the morning, it tends to be lower at the end of the day. You're releasing growth hormone at different periods through the night. Testosterone's high in the morning, it's gonna be lower in the afternoon. So there's all these factors. When did they, sample the blood? How was it 5 minutes after exercise? Was it an hour? Did they miss the window? And then if they're looking at muscle protein synthesis, when did they take that biopsy and when did they actually look at protein synthesis? I mean, if you miss the time point in the window, well then you could conclude there's nothing here. I mean,
well, yeah, so I think you hit the nail on the head. So you have to look in detail and kind of know the area to know, are we actually measuring at the right times? Are we measuring the right things? Was the exercise stimulus appropriate? You talk about the study design. I'm thinking of one study out of a number of them where there was a 12 or 15 week training period. That's pretty good training period.
Right.
Blood was only sampled for the hormonal response one time during week 7, but they extrapolated that out to the entire 15 weeks. Well, no wonder they didn't see anything, because it's, like you say, the timing, and just a single sample doesn't answer that. The other thing I would say is, if you know anything about statistics, a fairly simple statistic is looking at correlations. Is there a relationship, in this case, between how much, say, testosterone went up or didn't go up, or a number of hormones, and then how much growth did I have? And are they related to each other? Small increase leading to more growth, or smaller growth and large increases with more growth. Those correlations are hard to get. There's so many things going on that those are going to be subtle correlations. And when some individuals look and they say, this is not highly related, so let's throw this out. Hormones, the acute hormones don't mean anything. But they don't do the same analysis for the methods that they think are important. We do a lot of work in the muscle cell. We get muscle biopsies. We look at the signaling pathways. We see if they're turned off or not. Well, we should go back and run correlations on that, because everyone's saying this is what's going on. Well, where's your correlation? Well, that's hard to get a correlation there too, because it's such a complex combination. And but the miracle of it all is, what if one part of this complex physiological system, my body, isn't activated, all the other parts are, and so you can still get growth, and especially with untrained people.
Right.
Most of these studies are in untrained people. You go and take a highly trained elite group, and it's like, okay, untrained people, you can do almost anything.
Yeah, you can do anything. They'll get a training response.
And so that's something that I think you have to have a critical eye when you look at it. And these broad, very definitive, you're wrong, I'm right, throw everything you have out the door. It's like, wait a minute, this is, you have to look at it with an open mind, but you also have to have an informed mind to know what you're looking at.
Right. It kind of reminds me, I guess I'm picking on physicians here, but some physicians, not all, but they'll look at one number. They'll say, oh, your LDL cholesterol is 135, that's high. Immediately you need to go on a statin. Maybe, maybe not. But what are the other factors? I mean, just because the LDL is high doesn't mean you have atherosclerosis necessarily. I mean, if their blood sugar's fine, they don't have high blood pressure, they're not a smoker, they're active, and you're just picking one variable. Those other risk factors are good, but you're looking at just this one thing. It's like, well, you're just picking out one number, right? Kind of like in some of these studies. Let's look at the whole picture, right? So I think that has applications in a lot of different areas where it's like it's so easy to key in on just one thing that's elevated or off, or one specific factor, without looking at the whole picture. All right, so you'll stand your ground and say that acute increases in these anabolic hormones like testosterone, growth hormone, IGF-1, these acute increases do play a role in muscle growth.
Yeah, if you're an endocrinologist and if you do your homework in the muscle physiology side, you'll see, and I'll use testosterone as an example. And one good scenario is you have males and females. Clearly, and we're talking about your natural production of these hormones.
Yeah.
And clearly there's about a 10-fold difference between the average male, average female.
Although what's interesting, and sorry to cut you off, a lot of people don't realize this. I mean, just like testosterone obviously is 10 to 15 times higher in a male than a female, estrogen is also important in a male. If you look at females, testosterone, it's the units they reported in, testosterone in a female is actually higher than their estradiol levels. But, we always think of estrogen in females. It's important, both of those hormones in both sexes, to be in the appropriate ranges.
And it's a complex thing. I like the analogy I like to use is, over the infant's crib, you've got this little thing called a mobile, and there's shapes, or I don't know, it kind of floats around as this thing that's balanced. And that's sort of like your endocrine, your hormonal system. And things kind of fluctuate, and that mobile moves around, or it gets breezed or bumped, but it kind of maintains its balance overall, but it adjusts. And in some ways, your body is a little like that, and everything has to work together. But there is so much information on, a lot of people base everything on just how much, in this case, testosterone is circulating in your blood. Well, they haven't accounted for the binding proteins, they haven't accounted for the breakdown or metabolism of testosterone, what tissue has it passed through. You talk about the time point, how long till it degrades. They haven't talked about the receptors at the target tissue. Are the receptors turned on or not? Or how are they turned on? Are they the receptors in the cell, in the cytosol, the fluid part of your, let's say, muscle cell? Or there are receptors now we know that are in the membrane. There's other receptors they interact with. They interact with all these signaling pathways. They prime the receptors to respond more to the hormone. They prime these mechanical loading factors. It's like they have their fingers all over the place. And if you take away that hormone completely, and there's studies on that, and there's conditions on that, you lose the ability to have the same amount of muscle mass, and that's why testicular cancer patients, they have to have hormonal replacement therapy because they don't have that testosterone, because you need it. Now, I realize we're talking about the acute response, but that acute response, your body doesn't do things just willy-nilly.
Right.
And I know some critics have said, yeah, it's only dealing with metabolic factors. Well, I don't know what metabolic factors they're talking about for that hormone, So it's
Right.
kind of like, probably they don't understand what testosterone
Yeah.
does. So there are so many ways that these hormones work, and it's well documented in the literature. So just because their correlation between one sample in 15 weeks and muscle growth didn't come out, well, it's like, I believe it, but it's that's not the whole story.
And I remember, some of Bill Kramer's research, who you worked, with and in his lab, and he's looked at hormones as well. And it was kind of interesting. It looked like between sexes, there's differences too. Like, yeah, in males, you tend to see, depending on the type of workout, right, the program that you're doing, this acute increase in testosterone and growth hormone, IGF-1. In females, it looks like it's not so much testosterone, the spike you see after the workout, if it's appropriately designed. It's more growth hormone changes, IGF-1, things like that. So it's just kind of interesting, because that's another variable to look at. Well, what are the acute responses after a resistance training session in females versus males? And then, like you said, how's it travel through the blood, the tissue it goes through? When it binds to the receptor, I think a lot of people think of these anabolic hormones as they bind to the receptor in the cytosol, like you said. They translocate to the nucleus. They turn on genes. Those genes, transcribe an mRNA that gets translated into a protein. And so now you've got this protein synthesis. But there's so many other pathways inside the cell, proteins that are being phosphorylated and enzymes, and these hormones direct multiple things inside of a cell. It's not just as simple as, this one pathway that turns on protein synthesis. It's just amazing how many things that hormones control. So I think a lot of those other you're looking at this, like Justin Nichols' research and some of that, you're looking at these different pathways and the crosstalk between pathways and what's going on in the cell. It gets very complex. It's difficult to study.
And and you mentioned Dr. Nicole, who's out at Cal State Northridge now, but while he was here and working in our lab, he did some really nice stuff. And I'd also do a shout out to Stephanie Suntag, who's down in Oklahoma State, who continued some of that work. But looking at the connections, whether it's the hormones and these different signaling pathways that we know are affiliated with muscle growth, and there's a lot of interaction there. So I guess it could be discouraging. You say, well, it's just too complex. How are we ever going to figure it out? But to me, that's the miracle of the whole system.
So it makes it fun.
It works so well, and will I get it all figured out? No, I don't know. But at some point, the system works, and you can get a response. And to say the hormones and the immediate response has nothing to do, it's like, well, there actually is data that does show it does, but you got to look at the bigger picture. It's one of the pieces of the puzzle.
Right.
You're putting together that big jigsaw puzzle on your dining room table. Well, there's a lot of pieces to make everything work, and that's part of it.
I think you made a good point where the body doesn't just do things, I think you said, willy-nilly. It's like, well, there's obviously got to be a reason. Why do you see these spikes after a resistance training session, depending on again how it was designed, adequate load, the rest periods, these all play a role. But it's like, it's not just doing that for no reason. And then also, I think the problem too with this hormonal research and looking at the endocrine system, they're so focused on blood levels of total test and free test and things like that, and that's one component. But like we said, you've got to look at the receptor level. Is there an upregulation of receptors? Is there downregulation? Once it binds, what's going on in all those different pathways in the cell? That's so overlooked. Everyone just thinks concentration of a hormone, and that's just one part of the picture. All right, so we'll kind of move on. I think we've nailed that. It's fun to talk about. It's complex, but that's what makes the research fun, right?
Yeah,
is because the complexity, and like I always tell my students too, I was like, if you're naturally curious, and anybody that's thinking about going into research, I give it a shot, because this is the type of thing that feeds your curiosity. You have questions, you want answers, go into research, become a exercise scientist.
Yeah.
So, all right, I'm moving down my list of questions here, because some of these we've kind of already covered. So let me see, where are we at? Let's move on to testosterone replacement therapy, all right? Now, obviously, you're Dr. Fry, Ph.D., so you're not a medical doctor.
I'm a one of those. It's They say, you're a doctor, and you say, yeah, I'm a Ph.D. Oh, one of those.
Well, and where I was going with that was like, so this isn't medical advice. I'm basically asking your opinion here.
Yeah.
So based on your research, looking at the endocrine system, hormones, what do you think about testosterone replacement therapy? I mean, this is a hot topic. And if we're talking about physicians, you could ask 5 physicians that are endocrinologists, and they'll say, yeah, male gets over 40, their testosterone starts dropping. They should be on TRT, testosterone replacement therapy. You ask another 5, they're like, oh no, your prostate's gonna swell up, you're gonna get benign prostatic hypertrophy, or you may increase your risk of prostate cancer, even though that literature I've read through is very murky. I've also seen prostate cancer risk could actually increase if your testosterone levels are low. So that's murky research. But anyway, my point being, what are your thoughts on that, on TRT?
I probably won't give you much of an answer on that, but I do also want to differentiate that from, we're not talking about someone who's using, say, testosterone for performance enhancement purposes. So using it as a PED, performance enhancing drug, and especially for athletic competition.
Right.
It's on the banned list and so forth. And so in those cases, I'm not just replacing, I'm trying to get extra, a supra physiological dose.
Above the normal level.
So hormonal replacement therapies, other kinds of hormones are used all the time. Women use that, as it's related to menopause. And, there's, as with a lot of things, there's an upside and a downside. And I'm not the one to tell you the risks and, the pros and cons. That's up to your doctor, your attending physician. But the intention is something is missing that should be there. I mentioned earlier, maybe a cancer patient or someone has had some condition and they've lost their production of their hypogonadal, they don't produce enough, in this case, testosterone. And, during growth and maturation, some children, some young males have that problem. And so then there's in various manners they will, let's try to replace it and get you into normal ranges, because it has a huge impact on growth and sexual development, and also neural development and cognitive. And but you're talking about like with an older individual. Now, just so we're clear, we're not talking about me.
No.
Right?
Well, you're younger than I am,
but we'll say a mature person. But on a serious level, I'm of the age where I know my testosterone is lower. Guaranteed. I don't have to go measure it. I just know at my age, because that's a normal progression for men. So should I take a little bit and maintain at some level? Well, at what level? I'm not sure.
And that's a big question.
And and are there some risks? Health risks, most likely there's risk or adverse possibilities on a lot of medications, so I'm not sure what the current line of thought is. I know people do it.
Well, like
I used to have my own physician a number of years ago. He said my area is male menopause, he called it.
Andropause? They call it andropause.
And I thought that was interesting, because he was very much one of the, someone who said, yeah, absolutely. But it was, it's something that, you have to talk to your physician. And are you doing it for health reasons? Are you doing it for quality of life? What's the balance between, like you say, whether it's prostate, whether it's your blood lipids, and at what level that becomes an issue. Because
that can vary, and it's such a broad range. Even depending on the lab you go to, what's considered normal. It may be one lab. I don't know the exact numbers for, say, Quest, but they may say between 300 nanograms per deciliter up to 900 or 950 nanograms per deciliter. That's the normal range. I mean, that's such a broad range that it's like what is normal at different ages, and so I think some guys may have issues at a 500 nanogram per deciliter total T. Others may have no issues. Some may at 3, some may at 8 or 9. But like you said, I think that's important to drive home. The point is testosterone replacement therapy is to get you into a physiological range, not super physiological. This is not like using anabolic steroids to go above and beyond to gain a performance edge. It's just to get you to function how you're supposed to, right, in a normal range. And I see so much of this now, and I hear it all the time in gyms, and this is kind of going into, I guess, my next question or point is there's a lot of young kids out there. I mean, even 16, 17, 18, early 20s, when your testosterone is higher than it's ever going to be, that are taking anabolic steroids, and they think it's like TRT. And then they're like, man, you guys, you're going to shut your system down, your hypothalamic, pituitary, testicular axis. And I've talked to guys that are in their 30s and, their wife wants a baby and they're having trouble conceiving because, his natural testosterone production's tanked. His sperm count's low. The sperm aren't good swimmers. I mean, he's tanked it because of years of anabolic steroid use where it wasn't TRT, it was above and beyond that.
Well, I think, you bring up an interesting topic that one I would say there's a lot of pseudo experts out there on it, because you can read a lot of stuff on social media.
Bro science.
And there's several things to consider. One is and this is my opinion, but there's a lot more prevalence of that going on than most people realize. Because if you don't run in those circles, you have no idea. And this isn't just with taking anabolic steroids. It's any drug. If you don't run, or if you're not a pot smoker and I'm drug free and I'm clean and I don't know anybody, I have no idea how prevalent it is. Or if you run in those circles all the time, you probably have a pretty good idea of how readily available they are and how prevalent it is. And so I think there's a lot of, understandably, unless you happen to work or live in a certain community where you're aware of this. And so it's easy to get, from what I can tell. You just do a Google search and all kinds of websites come up, and are they legitimate? Is the stuff you buy legitimate? Good question, but I don't know. But they're also a banned thing because they are a performance enhancer. So if I'm an athlete that's going to be tested, now we're getting back to something that's closer to what this lab does. We don't do drug testing here, but we're talking about athletic performance. How do we help someone reach their potential? And I know I might be competing against someone who is an advantage because they're using pharmaceutical enhancement in some way, shape, or form. And the early research said, if for anabolic steroids, they said it doesn't really do much. Well, again, if you read carefully what they did, no wonder. It's almost impossible to do a controlled research study on that because it's not a pharmaceutical use. You're going off label, that type of thing. But there's an ethical issue, and now we're getting into a hot debate in some circles. Hey, the other team, the other country's doing it. Maybe I should. Give me a fair advantage. And then it's.
Ivan Drago and Rocky IV was using it, and Sylvester Stallone. Rocky, he was just up in the mountains in Siberia with a log on his back, right?
And I mean, I certainly have no particular insight, but you watch Hollywood movies, and it's like, okay, this guy's my age, and they're looking like a 21-year-old getting ready to join the Marine Corps, and it's like, who knows? Because there are people, and you have to be careful. There's I heard it called a reverse discrimination. Just because you're muscular and fit and everything doesn't mean that you're using anabolic steroids.
Yeah.
But it's a tough one, and I know I've been involved in sports in the past where you knew that they were present, and quite often people were very open about it. But you knew you accepted that. Is it fair? Probably not.
Yeah.
And people will say, yeah, but the same people will rise to the top. Yeah, well, that's assuming everyone's taking
Right.
it and taking the same amounts, and it's a mess, and it's illegal.
Right, right.
Period.
Yeah.
It's illegal.
Yep.
So a number of years ago when this was big in baseball, so you had the Bash brothers. You had Mark McGuire, you had Jose Canseco. They are setting records. They're bigger than everybody. And at the time, everyone in the media was saying, why would you even take this stuff? That's so ridiculous, because this is eye-hand coordination. Big muscles aren't going to help you, blah, blah, blah. Well, that's an uninformed population saying that, because to me it made real sense.
Balls were flying out of the park.
And so it's like people think it doesn't help you, it's not going to have an effect, and the reality is it really does. And unfortunately, sport governing bodies have to spend so much time and effort and money on drug testing. It's like you'd like them to be able to take those resources and be able to focus on coaching development, athlete development, studying training programs and all that, that stuff. But
And you know, going back to kids, I think about, because I talk to them all the time in the gyms, and this is just personal anecdotes. You know, I haven't sent out a survey or done a study looking at, you know, college-age kids and their use of anabolic steroids, but just, in the circles I'm in and being in the gym, I'm like, man, there's a lot of people using it, openly admitting it to me, you know, and it's like, they'll say, well, what are you on? And I'm like, because I've been accused, and I say, I'm just on weights, creatine, protein, and I tell them all the time, these young kids, I'm like, hey, get your training down, like learn how to train, get your diet right, learn how to rest and recover, learn how to take care of your body. Like, you know, I mean, but a lot of people, you know, obviously it's easier just to turn to the needle or pill than to look at those other factors. And same thing I even think with you know, older adults, guys that are in their, you know, 50s, 60s, 70s. It's like, yeah, your testosterone levels are going to be lower, but there's things you can do. For instance, if you lower your body fat, right? You lower your body fat, you have less of the enzyme aromatase floating around. Aromatase is what converts testosterone to estradiol, which you need, you know, some estrogen in your body, whether you're male or female. But if you have, you know, too much, and again, that balance gets off, that's an issue. But if you want to just an indirect way of increasing your testosterone, lose body fat, you know, as you get older. So it's, again, change your diet, exercise more. That's one way to boost your natural production. But it's like,
are you trying to tell me something? You trying to tell me something?
No, of course not. I am not. Gosh, how could you think I was implying that? All right, so I think kind of wrapping this up, one more question. It's been a fun talk. You know, I think about this year, the NSCA, the national conference, and, you know, Mike Stone, who you've worked with, big name in the field, great research, look him up, look at all he's done. He kind of talked about the future of sports performance and this area of research. And he mentioned, it was really interesting. He said, you know, we can all agree, like we've talked about, okay, well, yeah, if an athlete's using an anabolic steroid, you know, that's cheating. He's like, well, now if we look at where we're going with, I think he mentioned like CRISPR gene editing and some things like that. Now are we going to be creating like these super mutant athletes in 20, 30, 40, 50 years? I mean, who knows if we'll even be alive. Is that how they're going to be, quote, cheating now? Is you know, changes to their actual genome and their genetic makeup to, you know, increase the expression of a certain gene, or, you know, silence a certain gene? And, you know, I mean, where do you see the future of like athletic development and sports performance going? I mean, you think Mike's onto something there? You
know, and I'll make a few comments about Mike Stone. He's a good friend, and by the way, they put on a wonderful annual, they call it a coaches college, in where he's located at East Tennessee State University. Mike has extensive experience. It's interesting because he's been a coach at the world level, national level. He's been a competitor. He is extremely successful and prolific researcher. He's passionate about tying in the research and the practice.
And his wife too, wasn't she like the first Division I female strength coach? I think.
Yeah, Meg. Her name was Meg Ritchie at the time. She's Meg Stone now, and they worked together there. She still holds the NCAA, I think, discus record. She was a world-class shot put and discus thrower, and she was the first full-time female strength coach. when she was at Arizona, and later was at Texas Tech and has been at a number of places. But Mike Stone used to head up the sports science program at the U.S. Olympic Committee. So I mean, his connections and kind of knowing what's going on in the world of sport and sport performance and sport enhancement, he's someone to listen to. And so this whole field of sports science, which is what we do here, we do sports science, but that's still a hugely broad term. Well, what do you mean sports science? You know, we're sitting here in Lawrence, Kansas. This is the home, and he still lives here, and he still walks up and down our main street, which is Massachusetts Street, is Bill James. So if you've ever seen the movie Moneyball, well, a lot of that's based on some of the work he did. And he wasn't in it, but they refer to the work he did, and so you're analyzing, it's data analytics, it's game analytics, and he busted open that door. And so data analytics is sports science. Well, what about the person who is in the research lab and they're doing an experimental study? There's a control group and an experimental group, and we're doing biological measures, physiological measures, so forth. Well, that can be, if you're, depending on what you're studying, that can be sports science. How about doing stuff like we have right here? We're running up and down a lane, we're throwing baseballs, we're lifting weights on the platform. We're doing stuff, we're doing athlete monitoring, where teams come in and we test them, and so we're working directly with the athlete. Well, that's the practitioner maybe, that's sports science.
Applied, yeah.
I'm a strength coach, but I'm not called the strength coach now. I'm the director of player performance or something like that, because it's broader than that. I'm the person administering a lot of these tests. And so you have a broad range. There's a lot of things that can fall under the umbrella of sports science. And just like in a lot of fields, it's easy for them to be in silos.
Yeah.
And so part of the challenge, and that's part of the alliance that we're working with, there's some pretty impressive people that are colleagues of ours, and the goal partly is not to be in our little silos where I have no idea what they're doing, they have no idea what I'm doing, and you have to have the coaches and the athletes on board. You have to, otherwise there's no buy-in. And how do we know what we're studying is valid if the people that do this for a living full time don't see a value in it?
I think that's why those advisory boards and just transparency between, you know, what are the coaches doing, what's happening in the research in the lab, and you build that bridge. I mean, that's so important, because that's then what's directly going to benefit athletes and human health as well. There's one other thing I'm trying to remember. It's Friday. My brain is, I think, fried at this point.
They named that day after me.
Friday, that's good. But yeah, what I was going to say is, you know, we're talking about at the genetic level, you know, it used to be, when I see kind of how the field has evolved, even from when I was an undergrad, like in the late 90s, early 2000s, you know, we had a good understanding of how the human body functions at the systemic level, the organ level. Now it's moving down into tissue level, molecular, genetic. It's moved that way in, you know, studies for health and disease. Now it's moving that route, you know, in the sports performance field. And I just think it's really interesting. Like, I mean, I know they've done it, you know, some in Europe and other countries, probably in Russia, you know, looking at, say, even young children and looking at muscle fiber types and saying, oh, well, you've got a greater percentage of fast twitch or greater percentage of slow twitch. This child is going to be more likely to succeed if they have more slow twitch fibers, possibly at, you know, being an endurance athlete. Or this one may be, you know, a 100-meter sprinter because they're more fast twitch. So I think it's started to kind of infiltrate, looking at that, you know, cellular, molecular level into the sports science field. And I just thought it was interesting going back to Dr. Stone, Mike Stone said about, you know, how far is this going to go with trying to create this super athlete? It's like, yeah, there's ones that are using and abusing steroids, and then now is it going to go down to the genetic, manipulating the actual genetics? I mean, it's just, what are we going to see in 50, 100 years? You know, it's interesting to think about. But
yeah,
I think that's all I got. Long long interview. So anything else to add?
No, we're glad you came in here, and I would just invite you out here as often as you can, because we love talking shop with you, and every time we get together we think of some projects or mini projects or
I love hanging out in your office. I end up spending, I'm like, I've been here for 2.5, 3 hours. I actually got work to do. I got to go. But yeah, I enjoy it. We have
fun. I think maybe a parting word is, I think it's easy to look at what we do and say, gee, I wish you would spend your time looking at disease and health and stuff like that rather than sports. But I'm a firm believer that the value of sports is so huge on so many levels. One, kind of like the Alliance is using the study of elite sport performance to understand human potential, human physiology, human psychology, just what are all the pieces that can contribute to it. But also, sports is such a valuable part, or can be, when done well and correctly, it can be such a valuable piece of so many people's lives. As a participant, as a spectator, as and it has a huge impact. And can we do just a little bit to somewhere add to making that more attainable?
Yeah. And just nudging the needle a little bit.
Just nudging the needle a little bit. We don't have any false pretenses that we're going to figure it out and have the answers, but and it's such an enjoyable part of so many people's lives, and that we have it's fun being in here. And we just had a lab meeting this morning, and it was like we went over, because it is fun talking about this stuff and preparing and planning to do work related to sport performance.
And people that are interested in coming in, I mean, they can come in anytime. I know we're going to give your contact information here to close out the interview, but I mean, is it kind of an open door policy? Like, people are welcome to come in and check the lab out?
You know, we don't have like a visitation hour, but we're in room 208 in the Robinson Center, right across the street from Allen Fieldhouse on our campus. And our director of operations is, if he's not right by the front door, his name's Gabe. And if you do know you're coming, give us a call or an email, and whether I can show you around, or we have a number of grad students and undergrads that work and volunteer in here, we can show you around. And we have events too throughout the year, open houses and stuff like that. So yeah, it's we're glad to show you around, and everyone loves to talk about the things they're passionate about, and
right.
So you'll probably stay longer than you planned.
How can people contact you if they have questions about the lab, your research, and teaching?
They can contact me at my email at acfry@ku.edu, and our lab is located in the Robinson Center, right in the middle of the campus here at KU.
Yeah, and also want to kind of promote your new book, so Science and Practice of Strength Training. Dr. Fry co-authored this book with, I'll probably butcher this name, but Vladimir Zatsiorsky, famous Soviet strength coach, right? I mean,
researcher.
Yeah, researcher. He's authored a ton of papers and books in the field, and then also Bill Kramer, another big name in the field. So this text is loaded, I mean, with a variety of information for anyone really that's interested in strength training. So it's got chapters in there about strength training for youth, women, older adults. There's stuff in there on injury prevention, exercise selection, program design, the importance of velocity during training. So I think it's written in a way that really it's understandable, and people won't get too bogged down in trying to understand some of the science behind things, which sometimes for people that are in the field it's difficult. But I think it's pretty well written. So check out the book if you're interested in strength training, and doesn't matter if you're a coach, an athlete, or just somebody in the general public that's curious about how you can improve your strength, muscle mass, endurance, and your overall health. Yeah, and if you have any questions for me about the KU Exercise Science program, shoot me an email at jtaylor@ku.edu. or you can call me at 913-897-8516. Thanks for watching.